Hey guys, welcome back to the channel. This will be part 3 on the Jeep Wrangler with the oxygen sensor heater circuit problem. I am doing the test. I ordered a few of the ICs and just one out of like 12 is good. And this is the things that sometimes increases the value of a repair that you're trying to help somebody. So I have all the ICs in here. I just took one of the packages. That is the good one. That is the one I removed from the computer, which you can see still is removed, and that is one of the bad ones of all of these are bad. All right, so let me put you in the tripod. All right, you guys are now in the tripod. I'm going to set up the screen recording so you guys can see both results at the same time, and I'm going to explain a little bit of all the information I'm trying to or have tried to gather through this. All right, guys, so I have, as you see, probably here, hopefully, again, all the bad ones, the original one, and let me just make sure, put my glasses. Yeah, this is one of the ones on the package. They're all bad, only one good. So what I did is, as you can see, I took an image of the actual IC so I know the orientation. This has a mark in here. Hopefully you guys can see this cross in here, and it shows me pin 1. I have the data sheet from the component. Even though you cannot find this component in USA, you have to order to try, through overseas, and that's a problem because they send you whatever, right? The numbers match, but not the actual ICs. It's only one. So we have pin 5 as a ground, 4 outputs, 4 inputs, and then the status, and then the BCC, which is just the voltage the computer is using to send through the outputs, which in this case the computer is controlling the power side switching um, of the oxygen heaters. It has, you'll see on the wire diagrams if you go over to part 1 or 2, where the computer provides the power and they use for the heaters and a common ground for all the heaters. All right, so testing, I have, as you can see here, all the values, even though these are from the one I remove from the computer. All right, so what I'm using again the curve tracer. I am connected using one of the grounds, because this uses on the probe, you have to have a ground and then the test lead will be here. Um, so pin 5, which is right here on the top, is used for the ground on here. So I'm going to start with the test one. You will see differences in here immediately. Um, if I touch in here, we can see that they're close, but not the same. That's why we have no beeping. I go over to the next pin. It's the same thing. It's a little different, and I hope that that's enough for these to be a good IC, and then the one he has is a bad IC. Going on to the third pin, or fourth pin actually, as you can see, the image is different. And then the fifth pin is again different. So if I move over to the other side of the testing, which I think is pin 4, or test point 4, again, you can see here, if I go there, this one will match. Trying to hold it as steady as possible. Oh, I'm not in auto test, and that's why. So if I put this in auto test, now it's going to, if it matches, it will beep and then we'll go to the next point. All right, so as you can see that now the X is moving on the screen and we have a green dot that shows that all is good. All right, so that one is good. That one is good. That one is good. That one is good. And last, the BCC point. So all these areas on this IC are matching perfect with his, but the outputs are not. So this is for me enough to, because this is a very, very high tolerances on these IC. I'm going now to grab another IC. Hopefully I didn't broke that. No, it's still good. So that's the good. This is another new one, but it's not good. I'm going to show you what I'm talking about. Again, I'm going to just grab, this is a Pomona probe that is made for ICs. This will close and it will not allow to short to other pins on the ICs specifically for this. Very, very good uh, probes. All right, so I'm going to start now the test again. And we're going to start with point 0. Again, look at the X up at the top. And I connected ground on pin 5, which is the ground on the IC. So if I come here, see what is showing? The line going straight up. So see, that's a short. That is a ground. It's a direct short to ground. If I go over to the next one, it's a direct short to ground. If I go to the next one, it's now a different, it's like a resistance, but it's not short to ground. And then if I go to the next one, it's an open circuit. So all the outputs on these IC are shorted to ground. If I'm over to pin 5, or not pin 5, let me actually tell the correct number, pin 1. So we were checking from sorry, it's not even pin 1. So pin 5 is the ground, which so we check pins 4, 3, 2, and 1, and now I'm in pin 10, and we'll be moving from 10, 9, 8, 7, 6. So this will be pin 10, 9, 8, 7, 6, and this is pin 11, they call PCC, right? So let's see if at least those match, and I don't think they do. You see, it's something else. It's now an open. Usually when you have that, it means open circuit to the ground that I'm providing. So nothing is happening. When I move into now pin 9, we got the same thing. Pin 8, nothing. Pin 7, nothing. Pin 6, nothing. And then even here, nothing is open. So I definitely condemn these IC because, well, you will say, well, how you know is it good or is it bad? Because let's say, the one from the computer is bad. Well, we have to understand also, if we see here and understand the circuit of how is this designed, the outputs are going to be, when the IC is on, connected from BCC. I'm going to grab the mouser. So look for for the square that I'm now moving. So this BCC, when the IC is on, will be sending power to these outputs, which are these 4 pins in here. And this is ground. So if now the IC is off and this is shorted, when this is coming on, I'm suspecting that this will be shorted. And it's a little hard because um, the IC is not on. I'm not providing power or ground to it. The way that I can also try to check this up, it will be to put the ground and power this IC and see what it does. I can try to do that too. So what I'm trying to do, because we know by looking at the schematics on the IC, right? So we had BCC, which is going to be just connected from BCC 11, again, the bottom of this IC, to all the outputs when the input, which is going to be a square wave of 0 to 5, let's say, so whenever the input is activating, the output will come alive. So I can set that up. I can set definitely that up. I'm going to probably stop the video so I don't make this long. All right, guys. So what I'm doing in here, this is the no embed IC I have provide, and here I got on running from the signal generator. I know it's crowded in here, but believe me, I have supplying a a signal that is 0 to 5 volts. I have a ground on the ground pin, and then the 12 volts on the 12 volts, which is coming from my um, power supply. Nothing is happening. I have even a bulb here. I cannot move all this because it's very dangerous, but believe me, there is a bulb in here that's not doing nothing. The IC is not doing anything. Not and not on this output. And if one output is bad, all of them are bad. So I'm going to try this same thing. I'm going to turn the power off so we are not burning anything. And I'm going to try his IC with this same setup. So again, I'm going to remember this little notch in here. This is the one that's going to be telling me the position of the IC. So again, I'm using this Pomona um, probes to get everything to where I need it. All right, so his is here. I have kind of like bent a little bit his ground pin to get it off way because of what doing tests. And number one, this is, let's say, a bad one. So I'm going to use the ground in here. We're going to have the signal. This is the output. So we're going to have the output connected to one of the outputs. In this case, I'm using output number one. We have also, this is going to be, let me see. Yeah, this is the signal coming from the um, signal generator. So we need to put that onto signal number one. Output one, signal one, and now we're going to connect the power. These ICs are meant to, draw or be able to have a load of like over 1 amp. That's just the way they are. All right, so everything is in there. That one is on. Let me just confirm because I have my oscilloscope in here connected. You guys not going to be seeing this, but I want to make sure that yep, I have the square wave waveform, and let's turn this on. And you can see right there the light coming on. So that's 100%. I don't want to keep it on too much, but again, the same tests you can check and test an IC, and I am positive. Okay, so all those ICs that I got, all this is junk, garbage. I cannot use them. Only 1 out of 12. This is ridiculous. But I'm glad that I take the time to check everything before, because you know what? If I would have put those ICs and plugged in the computer, I would have probably, not probably, most likely burn the pads in the computer, because it's a direct short to ground in one of the outputs, and that output is for power and is designed to carry up to 1 amp, up to 1 amp. It's a direct short from the ground to 1 amp. That would have burned the pad. I'm so glad I did this. But so we got one good. This is again his. Pretty easy. Let me let me just revisit the IC. Let me actually start the screen recording. All right, perfect. All right, with this, now you guys can see everything really good. And now you are seeing also the oscilloscope and the screen. So what I'm going to do is show you the signal that I'm supplying from the arbitrary signal generator. They come with these leads that you can use. They have, the BNC on the one side and then two alligators. You've got to be careful where you're doing this. I want to show you that indeed I'm supplying a square wave with like 50%. So let me stop this. And you can see we got, like a little over the ground side. Let's say, that's like a right there. If I put, the other one up here, it's just like you see, it's a 5 volts signal from 372 millivolts to 5.4 volts. And we can also, if I use a match channel, actually, it's not a match channel. Let me just do a measurement. This is on Pico 7. You go to measurements and you can go over to do the cycle. Let me just, let's start to be cycle time right here. And no, that's the cycle time. I don't want that one. Yeah, delete the measurement, frequency, negative, positive duty cycle, I guess. Negative, oh, actually, it's the same. You can have negative duty cycle or positive duty cycle. Well, this is a positive, so, but you can see it's exactly in 50%. And by 50%, we can see that as soon as I turn that lamp on, okay, I'm going to turn the power supply on. this bulb illuminates, is drawing 160 milliamps. The reason I don't want to keep it on for longer is because the IC is not installed on the computer, and you don't want to, create too much heat and it's going to damage the IC. So what I'm going to show the connections again, going on to the data sheet like that. You guys also understand that this is indeed the exact data sheet for this component. So again, we have pin 5. I'm going to point. So again, remember the notch that I tell you guys to keep an eye on it. So if we see right here, we got this notch right here. So then BCC is 11, which is these big ones on the side. That's what I got the power. That's the BCC is going to go from the BCC to the outputs when we send the signal that is on the input. So we have connected this blue Pomona connector on input 1, which is in pin 10, and we got the output 1 on pin 1 going, let me just, yeah, going into, yeah, the test light that is connected to ground because this is supplying power, right? So the ground on the uh, IC is in pin 5, and then the signal, again, the blue Pomona is in the input 1. So these are the connections that I'm using, and you can check this IC based onto that. The only thing that I cannot check in here is the status. So the status, which is also part of the logic and diagnostics for this IC, is what is going to send the computer says, okay, this is drawing too much amperage or it's not working properly. We are not doing what we're supposed to do. And that's exactly what I cannot check. The only thing that I can do is replace the IC, right? One other thing that I would like to do is, since we got the oscilloscope here, and I haven't seen that, is to put the oscilloscope here, right? We're going to activate just briefly again the this IC, right? So we're going to um, erase all this because it's no longer what we need to do. So I'm going to turn it on, and we can turn it on in here. All right, I'm going to stop that, and I'm going to turn the power supply off. You saw the light coming on and off. And looking at the screen, we can see a little bit of a not too good signal. It's we got, should have probably, well, for what this is, it should be okay, but we can increase the sample rate because remember, when you have a very low sample rate, that can change the, I'm not sure this is actually good. So 1 millisecond was good. So let's do here. We're going to here, here. What is it? I thought it was display, pros, vertical. Why is not showing me? You have to click in here in samples. So we got the time base. We don't want to change that. We want to change the sample rate a little higher. Let's put, at least 1 mega sample because it's a little fast signal. It's not like super fast signal, but we want to make sure that we can see this properly. All right, so let's do it one more time, and then we can stop it. And I'm turning it off. Okay, so it's the same signal. We can see that now. We can now with that higher sample rate, we can activate a filter. Remember, the filters, you have to be careful when you apply a filter because you want to remove noise, but you don't want to change the signal shape. And that's what you can do. You see, all I'm trying to remove is this upper noise in here. So um, 4 megahertz should be just perfect. Even 3 megahertz, I think it's, yeah, 3 megahertz is perfect. So, all right, so now we can indeed put some cursors. Well, actually, it's saying that we have a 52.6 duty cycle. So we can remove this measurement. We're going to create another one. We just go over to, when you're working on Pico 7, if you don't have all this in here, you just go over to more, and you can now click on these stars. Whatever stars are selected are the ones are going to be in here. All right, so we can put a measurement and we can go over to positive duty cycle. Yes, indeed, we got 52.66. So I'm going to try the other IC, right, to see that how it looks. But as you can see here, these are not very straight lines, and this is the things that we don't, or maybe the computer doesn't like, because if we set up this in here, and now we can zoom, let me remove that in here. I'm going to put that here, and if 1 second, yes, yeah, tell him that I'm in the middle of something. He can wait for me a little bit. Tell him just wait for me a little bit, okay? Okay, so yes, so if we can see here, this is not a really good square waveform because remember the thresholds for these are probably what the computer is not liking. So I'm going to now set, remember this is the original, we got a known good one, or so not a known good one, we got a good one out of those. So let me set that one up and I'll be right back. All right, guys, so let me again stop the recording. All right, guys, I still got that one connected. I got a customer to come up with two more computers. He's a local shop that has diesel, uh, it's a diesel repair facility. So he brought me a computer for a Ford and another one for Cummins that they've been having problems with. Okay, so let me just remember his. I always try to make one is the one that has like this bent leg. So if you guys can see that in here. I'm going now to take this one up and now locate pin 5. Um, just to put this one in the same way. Okay, so I have to switch this like this. Yep. So this will be like looking in like that. I'm trying just to take a reference. Connecting the ground first. We're going to put the output 1. Output 1. Hopefully you guys can see a little bit what I'm doing. Input 1. And then the power. I'm going to put the bulb in here so we can see when this one comes on. All right, let me now start the screen recording. All right, guys, I got the screen recording. That was the old waveform. So let's run this now. We should have nothing perfectly on the screen. So I'm going to turn the power on for a second. We got power. Let's stop it. And then let's stop this. Let's go back. That was, when the voltage was coming down. Huh, that's funny. Oh, let me try that again. You see that decay at the end? See how it's going down and then nothing. I didn't see that on the other IC. Let's try one more time. All right, so I'm going to turn it on and then off. I'm going to see without the oscilloscope how the light shows off. And it goes completely down, so but it did the same thing, huh? You saw we do have difference. The other IC didn't do this. I'm happy. I like that. I like that. All right, let's go to one that is steady. All right, so I'm going to now open reference waveform. Again, look at my arrow. Hopefully it's showing in here. So you can just select here, and then I already saved the file before. If you want to add a file, you can add it from whatever channels you got in here, and then you save with the different colors or so. In this case, I already saved it, so I'm going to just open it up, and then we're going to put it in here on top of this. So there's looking pretty much the same, huh? I was hoping to see, a big difference. That's what, this is how you check things, You want to make sure that you can indeed, let me apply a filter. Do we have a filter active? It's not. Okay, so we put them into 4 megahertz, so 3 megahertz, another one, right? 4 megahertz. So we got, comparing tomatoes with tomatoes. Let's do a closer look. But yeah, looking in here, they look pretty much the same, right? A little bit of a difference, but nothing that I will say. At least, I mean, it's hard to say because I'm not the computer. We can see a little bit of an angle difference in here, from the wave for reference. And remember, we're catching this at the same speed with the same voltage. So this is a control environment test. And this is what is so important to do. But yeah, definitely we have some differences in the IC. We saw it on the curve tracer, and now we're seeing it in here. The other big difference that I didn't see on the other one is those last captures when it's, going down. You see, that is not what we saw on the other one. The other one was just on and off, right? So is this what the computer is not liking? I hope so. All right, guys, so I'm going to stop the video here. I'm going to, solder this back into the computer and then doing a test with the computer all connected. Make sure that nothing else shows up after you install, because you do have to apply a lot of heat on this computer to remove any components, because the case is part of, like, this is part of the cover. So it's not like other computers that you got just a board. There is, like this compositive material. This is actually on an aluminum lead that will try to dissipate all the heat too, right? So that makes hard to sometimes to remove components, but hopefully everything is good and I can put this back together. All right, guys, I'm going to stop the video here. Hopefully the other one will be the last video, and I will be recording it when I have also the answer from Keith checking this computer on the vehicle. Don't forget to subscribe. See you next time. Bye bye.